So as the title show for the day, so today we are going to be looking into what we call implementing your first machine learning-based model in what we call that is synonymous to what we usually say hello world ML model. Usually in programming, when people are starting for the first time, the first program that I have run is for them to say, okay, hello world. Are we able to print out hello world? So this is going to be more of such in our important clarification series. And this has been informed by some of the questions and requests I've been getting regarding some people that are really finding it difficult to lay their hand on their first project to move on. So like I've always encouraged us, everybody can use machine learning. And that is why we have this kind of program, we call it machine learning for all. You can actually implement machine learning without writing a single programming code. So using available packages, we call it no coding AI. That is, you can implement AI solutions without writing any program. If you know how to write a program, that is a plus for you. But if you don't know, that should not be a disadvantage for you in taking advantage of this fast-moving technology called AI, and the very important aspect of which is machine learning model. So machine learning modeling or machine learning, as the case may be. So today we are going to have a short hands-on demonstration of how we can go about it. I've got a couple of messages, questions, requesting that we don't know how to start, okay? So the place to start is, today we're going to make use of, you have to get a data set. Getting a data set is the starting point towards you implementing your first machine learning based model. So in this case, we are going to look at diabetes disease as a case study. So this has been selected because it's one of the very, very common diseases in the world today. Diabetes could be described as a chronic, that is, chronic means long-lasting health condition. There are some categories of diseases referred to as chronic diseases. That's once someone gets them, it can take a very long time before it could possibly be cured of such. And if it's not taken, you might not be able to get an end to it. So it is a chronic health condition that affects how your body turns food into energy. And usually your body breaks down most of the food you eat into sugar or glucose, and then releases it into the bloodstream. However, sometimes when the blood sugar goes up too much, then there's a signal that is sent to your pancreas to release insulin to control it. So sometimes something goes wrong, either the insulin is not being released, or something is already wrong with the pancreas itself, or it could be so many things could be responsible for that. But one way or the other, we've noticed that this is becoming, it's not just a pandemic, but becoming an epidemic, actually, yeah. Or as they call it, yeah, it's almost a pandemic now for people. So common a disease among people. So today we're going to look into if you want to build a model that can identify if somebody is diabetes. And I've actually been personally, I developed interest in this because I've heard of friends who have actually got chronic or even late diagnosis of this disease. Unfortunately, some of maybe the eyes already got affected, because it's very silent disease that it might be in the body of someone without noticing it. So, but with machine learning, this is one of the ethical and responsible utilization of AI that we always promote. So with AI or machine learning model, we can easily understand if somebody is having it at a very early stage before it actually gets worse, because the earlier, the better. Because according to medical practitioner, if diabetes is left untreated for a long time, it can even destroy the kidney, it can destroy the eyesight. So many other organs of the body could actually get affected, because if the excess blood, if the blood that is going to other organs is containing excess sugar, we know that's going to have effect on those organs. So therefore, if you want to run a model that can detect if this disease in someone's body, then you have to look at data. So like I said, this is a series on let the data speak. See, we always have this to say, let the data speak, because the data will go a long way to actually determine if there is a problem or if there is no problem, and if there's anything we can do about the problem. So always remember this, let the data speak. So without data set, you cannot build machine learning model. So your starting point is to look at the data set you can get. So what are the data set that we can look at for? What are the attributes? First of all, you have to identify what are the attributes that can possibly indicate that someone is suffering from this disease. We have a case here. Look at the age. These are basic data. These are feature. This is one feature. So this is another feature, gender, male or female. So is the person having high cholesterol level? What of the BMI? Do you have idea of the BMI of the person? Is he a smoker or not? Is there any history of heart attack or heart disease? Is the person always involved in physical activity, or is sedentary life, no physical activity? Not at all. So availability of fruits in their diets, lot of veggies. Is there presence of high blood pressure? These are some of the questions that could be looked into answering. And this information could be gotten from database of existing clinical centers or hospitals. So, of course, our target here is going to be the class. What we are looking for is the status of the person. Is it diabetes or not? And we should know this is a classification problem under which we are expected to have two classes. We have the positive class and the negative class. So positive means those that have been confirmed to suffer from this disease. And the other class is those that they are confirmed not to suffer from the disease. They are free of this disease. We need that tool, and then we can build a model that once anybody can then enter his own responses to some of these questions. When you enter your response to these questions, then the model develop. We then predict if that person is diabetes or non-diabetes. This is an instance. The question could be different from this. So that is why usually we ask the medical center or the clinic that is cooperating in such model building. It could be a client. Sometimes you could get a medical center that is asking you to come and build a machine learning model for them. So then ask them, what are the data sets you have? What are the features of your patient that are available? The more, the better. Then later we can use feature selection to be able to screen that some features that are not relevant, some are relevant. But at the beginning, sometimes you might not be able to tell. Sometimes you underrate a particular feature. You see, this attribute or characteristics is not necessary. For example, age. What has age got to do with diabetes? After all, this day we have a lot of children that are suffering from diabetes. You see? So what has age got to do with gender, either male or female? So no, you don't underrate any feature. You will get as many as you can, and then you move to the next stage where you're going to talk about building your model. Now, so this is one example of a possible set of features that could have been gotten for you. In another case, let's look at another possibility. Same, still on the diabetes case study. This is interview-based, in which case you don't even want any medical test that to be done on someone. See, we don't want anybody to check. For example, for the first data sample here, you need to check the blood pressure. So maybe you don't have it. There's no opportunity to do that. BMI calculation, Maybe these are peasant people, they don't know how to make this, or the gadget to use is not even available. So what of high cholesterol? Sometimes maybe it's not also available because you have to go to a medical center to do some tests. So sometimes maybe your data set is very simple. It's an interview-based data set. It's one of the project idea we're trying to actually work on that. Features that all these questions can be answered at a go by a patient. A medical practitioner or a nurse or anyone who is aware of these terminologies can go into a particular setting, meet people individually to get as many data sets as possible. It has the age, you have the gender, you have the urea, the polydyspia. These are basic questions you can ask based on explanation of the meaning to the person involved. They can answer the question either it's present in them or not, without necessarily doing a lot of any medical test. Did you express sudden weight loss, weaknesses in the limb and hands or bodies generally, genital thrush and visual blurring? Did you experience visual blurring? Do you experience itching in any part of the body? Irritability? Did you suffer from delayed healing? Is there any delay in the healing? Maybe there is something that caught your body. Did you notice that, unlike the past, that within few days, the part of the body is almost healed up, but now it took almost 2 weeks for very simple cut to go away. Even a simple bruise might not go away until a very long period of time. These are some of the lookout symptoms or signs that, hey, something might not be okay in the system. So these are basic questions: partial paresis, muscle stiffness, and then obesity, alopecia. These are basic questions that can be asked from people. Either they are visiting the clinic, somebody can start getting their responses. So we're going to have these two cases, and then we're going to see, once we have your data set, we check it, then the first thing is to put it in a kind of a format that the machine learning algorithm or model can be built using them. So we are now going to look into sample answers to some of these questions that have been framed. So we got some data set in this respect, so that each patient that have been at the interview or a person that might be interviewed, these are some of the response. So for the first case, we're going to look into, let's look at the data set. Let's look at the data set. Yeah, these are the data set. So we can see here, these are some of the responses. You have the age, you have gender, you have the high cholesterol, or what discussed for the first case. Is a smoker? Is there any heart disease? Physical activity, fruit, veggies. These are answers for this. We call it sample. This is sample one, sample number one, the first person data. So we can see some of the questions are high BP. 1 means yes, usually, and 0 means no, not available. So you have BMI, and then you see, keep having the question, another one, another one, another one. So as many as possible we can get. The more we get, the better. And then these are the diagnoses. You can see here, this is the status. This person, this is the class we are targeting. So this person is not diabetes. You can see. You keep going. No, 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 no. So we have so much data set here presently. You can see, you keep going down at the point you start seeing people that are having yes. See, you have cases of yes. You can see the yes, the age is there. Yeah, so what are unique? You can see a lot of things that used to be 0 here are starting to be 1, 1, 1. Maybe these are the culprits to pay attention to. Is it why they are diabetes? So anyway, this is the data set. So you have to get your data set from your area, any area of your interest. So identify the possible features, and then, of course, you have the target, and then try to extract data for each of the category that you have identified. Then having done this, so this is our data now. you have to make sure that this is saved. This is Excel file. But make sure you save it as CSV. See, you have to save it as CSV because we are going to use Weka machine learning modeling environment. So it doesn't work directly with the Excel. So you have to save it as CSV file. CSV file. So this is CSV file. So you have to save it as CSV. Once it is saved, then you can then open. This is for the first data set. Now for the second data set also, we equally got some samples. This is the one, this is the interview base, whereby you don't need to actually carry out any medical test. So this is the age, the gender, and all those questions being asked. They are all yes or no questions. Yeah. Do you have irritability problem? No. So is there any case obesity? We all know what is obesity. So do you have itching? Yes, no, yes, no. Is there any idea of visual blurring? Your eyesight is not good. Sometimes people feel that they just need to increase the power of their glasses, not knowing that diabetes is already hitting deeper. So these are some of the questions. Based on this question, personally, I'm more interested in this kind of interview-based data set, because that means people does not have to spend any money to get their data set investigated to be able to determine if they are suffering from a disease or not, especially diabetes. So these are the class. This is the class we are looking to. You have positive cases. Positive means the person is diabetes. So while negative means is not. We have cases of negative also. You can see most of the negative cases, there are a lot of no in the answers. Very few yes, because some of those things, yes, indicated that there could be presence of diabetes we are looking at. So once your data set is arranged and you save it in the form of CSV file, then you are ready to go on to run your first machine learning model building steps. So the next is, let me open, I'm going to open a Weka. For those that, for the first time, this is a software called Weka. So you can easily download it. It's free. It's available for free. You can download it on your machine. It's at 64, 32-bit, whatever version you are using. So once you install it, we are going to be working here on the Explorer. So when you click the Explorer, it will open a window for you. So to open a window, in this window, yeah. Once you click the Explorer, it will open it opens a window for you. So from the window, it's going to open. Then this is where we're going to do the modeling. So seems it's loading. Yeah. So the Explorer is ready now. So we can see here in the Explorer, every other thing is blur out. So the only thing here is pre-processing. So we have to, first of all, input our data set. So the data set we have prepared. We have prepared our data set that is responses to each of those features have been recorded. So we have to open the data file. So open the data file. So we have Weka. Yeah, this one we're going to use. We call it the Hello World ML. Yeah. You can see here, even though the files are there, but we cannot see it because by default, Weka is looking for a file of type star.aff. Star.arff. Star.arff. This is what it's looking for. So we have to change it to all CSV. We are looking for CSV file. So now we can see we can see here. So we can use the first one, or we can use the interview base. So if you go for the interview base, you open the data. Now the data is opened. So once you open the data, all the capabilities of the Weka environment becomes possible or become available. So then you go to classify. This is where you want to determine so which of the data set is positive, which one is not positive. Because the system now is trying to study the characteristics that is making somebody to be positive to the disease and the one that is making them not to be positive. So if we can be able to build a model with very high accuracy or very excellent performance measures, then it means we can rely on such model to check for people. Anybody that comes later, just get their data on those features and then come up with their decision whether they need to check themselves because the system has identified them as having diabetes or otherwise. So now we move on. We are going to choose this is why we're going to choose this classifier we want to use. So, and there are various types of classifier you can work with. So I usually like to start with, because of the starting point, we call one IBK, which is K nearest neighbor. It's a very simple classifier, very easier to explain to people. So we're going to select IBK. So IBK is our classifier. So this is K nearest neighbor. It works on the principle of show me your friend, I tell you the kind of person you are. If somebody is nearer to you and is suffering from a particular disease, maybe you might also be suffering from it. So depending on how closely related your characteristics or features that have been gathered are. So once we have selected that, so we can click this button and then that will open up. This is the K nearest neighbor. We can set the number of K. The default is 1, which is fine. And also the distance measure. These are the hyperparameters. So though we already had our earlier videos already described some of these things in details, but so we'll not be spending more time on that. So that just to make it easier for everybody to see that you can actually start and run your first ML model within a couple of minutes. So the next thing is we need to set how do you want to partition the data, because we need to partition our data. So usually we can partition into split form, in which case we can decide to make like 70% for training, 70% for training, and then we can the remaining 30% will be for testing. Or we want to make it cross-validation. So this concept also we've explained in our previous sessions, where it's going to partition into 10 portions. 9 of them will be used for training at every point in time. The 10th portion will be used for testing. And this will be repeated 10 times, with each portion being used as testing set at least one time. At the end of the day, we are going to find the average of the 10 runs to be able to know how the system is going to perform. So either you use cross-validation or percentage split is all fine. But let's go for cross-validation and then see what we are going to get. So once we have selected that, then you are ready to click the run button, start. Once you click start, then the system will build a model for you. Yeah, the model is built already. So that is using 10-fold cross-validation. And this is the result. This is the result. So the result is saying these are the correctly classified model. You can see all these are all indication here. We are using 10-fold cross-validation. Time taken is so fast. Yeah, correctly classified instances, 510. These are correctly classified, and 10 are incorrectly classified. So the percentage accuracy for now is 98%. 98%. It means 98% of the data set has been correctly identified, where only approximately 2% has been wrongly classified. So then these are the other performance measures. again, which we have discussed in some of our earlier engagements, and we also hope to have opportunity to elaborate more on them as we move on in this series. So the first thing now is that what you have done is now you have successfully run your first machine learning model building. You have successfully built a model, and this is the result of the model. See, this is the result of the model you have built. Those are the attributes used. Those are the number of instances. 520 instances has been used. 70 attributes has been used. And then here is the result. 90% accuracy. 98 out of 100, that is excellent by any standard. However, in medical, we always want to get as close as possible to 100%. So this is how you can easily run your first machine learning model. So these are other performance measure, the true positive rate, the precision, the record, the F measure, all those, they are for discussion in our earlier system. And if need be, we can then discuss them later on. And this is what we call confusion matrix. Confusion matrix will tell us more details, the actual outcomes. You see, these are the true. You can see the true. We're going to have the true positive, and then this is the true negative. True positive means 112 people, they were actually sick, and the system identified them as sick. This is correct prediction. In 198, this is true negative. It means there are 198 people who are not diabetes, and the system also identified them as non-diabetes. However, there are two errors. This is one error here. This is false positive, and this is false negative. False positive means these are people who are not sick, but the system has predicted that they are sick. You see? So we also have false negative. See? Those are ones that are originally, they are actually positive, but the system has predicted them to be negative, or as the case may be. So these are the error column, so error boundary, the diagonal for error 8 and 2, and this is the diagonal for the correct classification. It means these mistakes are coming from the 2% that we have identified that they are having issue. But however, 90% to start with is a good thing. So how do we improve it further? That is when we're going to talk about how to adjust the hyperparameters of our model. So you have to go back again and then identify the hyperparameters. For example, this is one hyperparameter for KNN is K. One of the very important ones is K. We can make it to be 3 because the number of classes is 2 classes, yes or no. So we make it to be 3. Someone may want to ask, why don't we make it 2? We don't make it 2 because there could be a tie, because there's a voting going on. See, the system can say, okay, 2 of them are closer, 1 is not close. So we can actually make a decision if you are odd numbers. When you have even numbers and the number of classes is also even, then we are going to have problem of voting in that case. So we can make it into 3 and then click OK, and then you can run it again. You can see here, even though we increase the number of hyperparameter K to 3, it brought down the performance measure from 98% to 93%. You can see it reduced the performance. It means for this data set, 1K equal to 1 is working for the data set. And again, that reminds us of what we say at the beginning of our presentation, that let the data speak. Ordinarily, we wanted to see that, okay, the more the number of K, maybe the more the accuracy will increase. In this case, it seems it's not so. Then we can try K is equal to 5, K is equal to 7, and so on, until we get the best possible accurate result we can get, and then we can start reporting our work. So, but then at this level, this is how you can run your quick model, irrespective of the area that actually your work is coming from. So get your data set ready, which we actually show us here. So we have just used the interview data set. So once the data is ready, so open your Weka, which we have done also, and then run from the Weka main page, click Explorer, which will give you the Weka Explorer. Then you can open your preprocessor here. You can get your data in, and then you can classify. This is where you can select which classification to use. And then there are some other things you can check about your data set. What are the attributes of the data set and also of others? So for sure, we are going to be continuing with such hopefully in the next presentations. But at least for now, so hopefully we can be able to see that anyone can easily get your data, identify the kind of data set you want to use. So, and then once you get the data set, get it into an Excel, some of the responses based on the defined attributes you are having. And then once you have the attributes properly documented responses in your Excel file, convert the Excel file into a CSV file, for that is what is recognizable to the Weka environment. And then you can load your data. And once you load your data, you can run your first machine learning model, as simple as that. So, and this is also applicable to any other field that you want to actually implement machine learning for. So I believe this is what we are going to have on this today. So we are going to continue from there next time. We are going to have a questions segment. If there's anything that's not clear on the basic thing we have presented, then so we can actually raise our questions and then we're going to answer them. Once again, thank you very much for listening and wish you all the best. Thank you.